Welcome back, everybody, to another deep dive. This time, we're diving into something that's really shaking things up in software development.
Oh, yeah.
It seems like the whole world's going crazy for AI these days.
Right.
But the thing that's got me really hooked is how it's changing the way we build software.
What I find so exciting is how AI is shifting from being just another tool to becoming more of a collaborative partner,
Yeah.
particularly in coding,
Yeah.
which is really fascinating.
Exactly. And, we're not talking about some sci-fi scenario where robots are taking over and kicking developers to the curb.
Right.
This deep dive is all about figuring out how humans and AI can team up, each bringing their A game to the table.
Absolutely.
And what's even cooler is that our main source for all this is a brand new research paper hot off the press.
Oh, wow.
So we're getting insights straight from the bleeding edge of this field, which is pretty exciting.
It's always so refreshing to see research that not only introduces new concepts, but actually puts them to the test
Yeah,
in real-world scenarios,
Yeah.
because that's where the rubber meets the road.
exactly. So let's get down to brass tacks.
Okay.
This research team, they didn't just stay in the lab, they went out and teamed up with Atlassian.
Oh, wow.
Now, if that name doesn't ring a bell, they're the masterminds behind tools like JIRA, which is basically the holy grail for keeping development teams organized and on track.
It's like the industry standard.
Oh, absolutely. And get this, Atlassian operates on a scale that's just mind-blowing.
Oh, yeah.
They've got over 12,000 engineers on their team.
That's huge.
I know, right? And in just 1 year, they crank out over 950,000 pull requests.
Wow.
That's a mountain of code.
It's hard to even fathom that volume of work.
Yeah, you can just imagine the kind of challenges that come with managing that sheer volume of code.
For sure. And that's where this innovative framework they're working with comes in. It's called HULA.
LQLA, okay.
And it stands for Human-in-the-Loop LLM-based agents.
All right, so before my mind goes straight to someone dancing the hula, can you tell me, is this some kind of new software that we can download?
Well, it's not a piece of software you install on your computer.
Okay.
Think of it more like a blueprint or a set of guidelines, really,
Okay.
for how AI and human developers can work together, like a structured collaboration.
I like that, a blueprint.
Yeah, it's a framework
Okay.
that breaks down the whole software development process into these 3 distinct agents.
Agents. Intriguing.
And the best part is you, as the developer, are one of them.
All right, I'm hooked. Break it down for me. What are these agents all about?
Okay, so picture this. You're tackling a really complex coding task.
Right.
The first agent to step onto the scene is the AI planner agent.
Okay.
This AI, it's like a superpowered detective.
Yeah.
Scouring through your code base, analyzing the task, and figuring out exactly which files need to be changed.
So the AI planner agent is basically giving us a roadmap, like, hey, focus your energy over here.
You got it. It's
Yeah.
like having a super smart assistant highlighting the key areas that need attention.
I like it.
Then comes the AI coding agent, and this is where the magic really happens. Okay. This agent takes that plan from the planner agent
Yeah.
and actually writes the code changes based on those instructions.
So it's actually writing the code.
It is, yeah. Imagine having a coding whiz by your side, generating code at lightning speed based on your specific instructions.
All right, so now I'm seeing the potential here.
Right.
But I have to ask, where do I fit in as the human developer in this whole setup?
That's the best part. You are the third and most crucial agent,
All right,
the human agent.
the human agent.
And your role is absolute critical. You're not just sitting back and watching the AI do its thing.
Okay.
You're reviewing the code that the AI has generated, making sure it aligns with the overall goals of the project.
Yeah.
And most importantly, bringing your uniquely human skills to the table, things that AI still can't replicate.
Like what?
Things like your creativity, your ability to think outside the box, solve problems in ingenious ways,
Yeah.
and to make those subtle, nuanced decisions that AI, at least for now,
Yeah.
just can't quite grasp.
See, this is what really gets me excited about this whole thing.
Yeah.
Because it's not about AI coming in and stealing our jobs.
No.
It's about AI becoming this super talented assistant
Exactly.
that takes care of some of the heavy lifting,
Right.
freeing us up to focus on the big picture stuff, the things that really require that human touch.
You nailed it. It's all about augmentation,
Yeah,
not replacement.
I love that. Augmentation, not replacement.
And that's precisely what the researchers behind HULA emphasized.
Okay.
This isn't about making developers obsolete.
Yeah.
It's about empowering them to do even more.
Now, any researcher worth their salt knows that it's not enough to just talk about theories. They've got to put them to the test.
Absolutely.
And that's exactly what this team did. They took their HULA framework for a spin in the real world, right in the heart of Atlassian's development process.
That's where you really see if it holds up.
Oh yeah, no better proving ground than that.
And they didn't just dive in head first. They had a really smart 3-stage evaluation plan.
Oh, okay, so tell me about these stages. How'd they go about testing this thing?
Okay, so the first stage was all about offline testing.
Offline testing, okay.
They used benchmark datasets, basically collections of coding challenges,
Okay.
to see how HULA performed on its own without any human intervention.
So no hand-holding.
Exactly. They needed a baseline to see how the AI would tackle these problems compared to how human developers typically solve them.
Makes sense. So what data sets did they use?
One was SWE-Bench, which is a pretty well-known collection of open source coding tasks.
Oh, okay, I've heard of that one.
Yeah, it's a good benchmark for this kind of research.
All right.
But they didn't stop there. They also incorporated an internal dataset from Atlassian,
Oh, interesting.
which is really valuable because it gives us a glimpse into how HULA handles the kind of complex real-world code that Atlassian's engineers work with every day.
That's a really smart move, comparing it against both a standard benchmark and a real-world data set.
Right, because the real world is messy.
Oh yeah, it's not always as clean and predictable as those benchmark data sets.
Exactly. So by testing HULA on both, they could get a much more comprehensive view of its capabilities.
So what were the big takeaways from these offline tests? What really stood out to you?
Well, one thing that really jumped out at me was the difference in performance between the two datasets.
Oh, okay. How?
So with SWE-Bench, HULA was a rock star when it came to file localization.
File localization, what does that mean in this context?
It's all about accurately identifying which files in the codebase actually need to be changed to address the coding challenge.
Oh, okay. So like pinpointing where the action needs to happen.
Exactly. And with SWE-Bench, HULA nailed it, 86% accuracy.
86%, that's impressive.
It is, right. But here's the thing. When they tested it on the Atlassian dataset, that accuracy dropped to 30%.
Wow, that's a pretty significant drop. Why do you think that happened?
It's not that HULA suddenly became worse. It actually highlights a really important point about AI, which is that it's still very much context dependent.
So the AI is better at tackling problems that are similar to what it's already seen in its training data, kind of like how we humans learn best through experience.
That's a great way to put it. It's like if you've only ever baked chocolate chip cookies, you might struggle a bit when you first try to make a cheesecake.
Right, even though the basic principles of baking are the same, each recipe has its own quirks.
Exactly. And the researchers pointed out that the Atlassian issues, those JIRA tickets, they tend to be shorter and less detailed than the open source issues in SWE-Bench.
Ah, so the AI might be missing some crucial context when it's working with those more concise descriptions.
That's exactly it. And that lack of context can make it a lot harder for the AI to figure out exactly what needs to be done.
Which brings us back to why having a human in the loop is so important.
Absolutely.
We can fill in those gaps, provide that extra context that the AI might be missing.
You're spot on. We're the bridge between the AI's capabilities and the nuances of the real world.
So stage 1, offline testing, provided some really interesting insights into how HULA performs on its own.
It did. We got a good look at its strengths and its limitations.
But now I'm really curious about how it actually performs when you throw real developers into the mix.
Well, that's what stage 2 is all about.
All right, let's dive into that then.
So for stage 2, they actually deployed HULA within Atlassian.
Oh, wow. So they let it loose in the wild.
They did. But they were smart about it. They rolled it out gradually.
Okay, good. You don't want to just unleash a new AI onto an unsuspecting team of developers.
Exactly. They started with a small group of engineers, just to get a feel for how things would go.
Like a pilot program.
Exactly. And then, as they gained more confidence and saw positive results, they expanded it to larger teams.
So this real-world testing was all about observing how the AI and the human developers actually interacted with each other.
That's the core of it. They wanted to see how this collaboration would play out in practice.
Did they have any specific things they were tracking during this stage?
Oh, absolutely. They meticulously tracked several key metrics, like the plan approval rate, basically how often the developers agreed with the plans generated by the AI planner agent.
Makes sense. If the developers are constantly rejecting the AI's plans, that's a sign that something's not quite working right.
Right. It would suggest a disconnect between the AI's understanding of the task and what the developers actually need.
So that approval rate is a good indicator of how effectively the AI is performing its role.
Exactly. And they also track the PR merge rate.
PR merge rate. Now, for those of our listeners who aren't immersed in the software development world, can you quickly explain what a PR is?
Sure, PR stands for pull request.
Okay.
It's basically how developers propose changes to the code base.
Okay, so it's like a formal request to integrate your code changes into the main project.
You got it. So the PR merge rate tells us how often the AI-assisted code changes were actually incorporated into the final product.
Ah, okay, so this is the ultimate measure of success, the percentage of those AI-generated code changes that actually made it into the real deal.
Exactly. It shows us how valuable the AI's contributions were in the eyes of the human developers.
So stage 2 is all about gathering data, really digging into the nitty-gritty of how this human-AI collaboration played out.
It was. They wanted to go beyond just theory and see how ULA performed in the real world, warts and all.
Okay, and to wrap things up, what about stage 3? What did that involve?
Well, for stage 3, they decided to go straight to the source.
Okay.
They conducted a survey of all the Atlassian developers who had used ULA during that stage 2 testing.
Oh, I love that, getting the first-hand perspectives of the people who are actually using this thing day in and day out.
Right, because data is great, but there's nothing like hearing directly from the humans at the heart of it all.
So what were they trying to learn from this survey? What kinds of questions were they asking?
Well, they were really interested in things like developer satisfaction. Did they find ULA to be helpful?
Okay, so like, were they happy with the quality of the code the AI was generating?
Exactly. They also asked about the perceived benefits and challenges of using ULA.
So getting a sense of the pros and cons from the developer's point of view.
That's it. They wanted to understand the overall developer experience, both the good and the bad.
This is really fascinating to me because it goes beyond just those cold, hard numbers.
Yeah, the numbers are important, but they don't tell the whole story.
Exactly. And it sounds like this survey was a way to add that human element, that qualitative layer to the quantitative data they'd already gathered.
That's a great way to put it. They wanted to understand not just how HULA performed, but how it impacted the developers who were using it.
Okay, so we've laid the groundwork here. We've got this incredible HULA framework that's being tested in the thick of things at a company known for its innovative engineering culture.
It's a perfect testing ground.
It really is. And we've got the initial results from the offline tests, the real-world deployment, and the promise of insights directly from the developers who used HULA.
It's all coming together.
Now, get ready, folks, because in part 2, we're going to dive into the nitty-gritty of those evaluation results.
We're going to uncover what worked, what didn't, and what surprised even the researchers themselves.
Stay tuned.
Okay, so let's unpack those evaluation results, shall we?
I'm all ears.
All right, so remember that plan approval rate we talked about earlier?
Yeah, the one that tells us how often the developers are giving the AI's plans a thumbs up.
That's the one. Well, it turns out that approval rate was a whopping 82%.
82%, that's pretty impressive.
It is, right. It means that in the vast majority of cases,
Yeah.
the AI planner agent was able to come up with a plan that made sense to the human developers.
So it was passing the human sniff test, so to speak.
Yeah, it was demonstrating a good understanding of the task at hand.
Okay, so that's a good sign. But what about the actual code generation, the rubber meets the road part of this whole thing?
Right, that's where it gets even more interesting.
Okay, tell me more.
So the researchers focused on two key metrics here.
All right.
The raised PR rate and the merged PR rate.
Now, I know we talked about PRs before, but just for those who might have missed it, can you give us a quick refresher on what a PR is?
Absolutely. PR stands for pull request.
Okay.
And it's essentially how developers propose changes to the code base.
So it's like saying, hey, I think we should make this change. What do you all think?
Exactly. It's a way to get feedback and approval before those changes are integrated into the main project.
All right, so back to those rates. What do they tell us?
So the raised PR rate tells us how often developers felt confident enough in the AI-generated code to actually submit a pull request for review.
Okay, so it's a measure of how often the AI's code was considered good enough to even be considered for integration.
Precisely. And then the merged PR rate tells us how often those AI-assisted pull requests were actually accepted and merged into the final product.
Ah, so that's the ultimate test, the percentage of AI-generated code that actually made it into the real deal.
Exactly. It gives us a sense of how much the AI was actually contributing to the development process.
All right, drum roll, please. What were those rates?
Okay, so the raised PR rate was 25%.
25%, okay.
And the merged PR rate was 59%.
Those numbers are interesting. They're lower than the plan approval rate. What do you make of that?
Well, I think it suggests that while the AI is really good at coming up with plans,
Yeah.
it still has some room for improvement when it comes to actually generating the code.
That makes sense. I mean, we're talking about real-world code bases here. These things can get incredibly complex.
Oh, absolutely. Translating a plan into flawless, production-ready code is no small feat.
But hey, almost 60% of the raised PRs getting merged. That's still pretty impressive.
It is. It means that in a significant number of cases, the AI was generating code that was good enough to be refined and used by the human developers.
So it's not a complete replacement for human coders, but it's definitely a valuable tool that can help speed up the process.
Right. And I think it really highlights the iterative nature of this whole human-in-the-loop approach.
Yeah, it's not about expecting the AI to be perfect right out of the box.
Yeah. No, it's about humans and AI working together, learning from each other, and constantly improving.
Okay, so let's shift gears for a moment and talk about the developer survey.
All right, let's hear what the humans have to say.
I'm really curious to get their take on this whole thing. Were they excited about working with AI? Were they terrified that the robots were coming for their jobs?
Well, the survey responses were incredibly insightful. One of the things that really stood out was that 61% of the developers agreed that the AI-generated code was easy to read and modify.
That's huge. Because even if the code isn't perfect,
Right.
if it's easy to understand and work with, that's a major win for the developers.
Absolutely. It means they're not fighting against the AI. They're able to collaborate with it effectively.
So it's not this mysterious black box spitting out code that nobody can decipher.
Exactly. The AI is generating code that fits into their workflow, which is really important.
Okay, so that's a big plus. What about the other side of the coin? Were there any areas where the AI fell short?
Well, one of the key questions they asked was whether the AI-generated code effectively solved the task at hand.
So it's one thing for the code to be readable, but did it actually do what it was supposed to do?
Right, and only 33% of the developers agreed that it did.
33%. That's a pretty significant gap between code that's easy to work with and code that actually gets the job done.
It is, and I think it underscores the fact that we still need those human developers.
Yeah, they're the ones who can ensure that the AI's output is not only readable, but also functionally sound and meets all the requirements of the task.
Precisely, they're bringing that critical thinking and problem-solving expertise to the table.
Okay, so we've talked about readability and functionality. What about the bigger picture? Did the developers feel like HULA was actually saving them time and effort?
That was one of the most consistent themes that emerged from the survey.
Oh, really? Tell me more.
Developers repeatedly mentioned that HULA helped them reduce their initial development time,
Okay.
especially for those more straightforward, repetitive tasks.
So it's like having an extra pair of hands to handle those more mundane aspects of coding.
Exactly. It frees up the developers to focus on the more complex, creative, and challenging aspects of their work.
Which is where they really shine.
Precisely. It allows them to leverage their unique human skills where they matter most.
All right, so it sounds like there are some definite benefits to using a system like HULA.
There are. The potential for increased efficiency and developer satisfaction is pretty clear.
But I'm sure it's not all sunshine and roses. Were there any challenges or pain points that the developers highlighted?
Of course, no system is perfect, and the developers were very upfront about the challenges they faced.
All right, let's hear about those. What were some of the things that tripped them up?
Well, the most common challenge was, you guessed it, code functionality.
Back to that 33%.
Yeah, even though the developers found the AI-generated code to be readable, it didn't always work as intended.
Which makes sense given what we discussed earlier about AI being context-dependent. It can be hard for the AI to fully grasp all the nuances of a complex code base and generate code that integrates perfectly with everything else.
Exactly. And sometimes the code might work in isolation, but then when you try to integrate it into the larger project, things start to break down.
Okay, so code functionality was a big one. What else?
Another hurdle was the level of effort required to provide really detailed issue descriptions.
Remember that whole discussion about agile-style JIRA tickets versus those super detailed open-source issues?
Right, because the AI needs clear, comprehensive instructions to really do its best work.
It's like the old saying, garbage in, garbage out.
Exactly. If you feed the AI vague or incomplete information, you're not going to get great results.
So the developers found themselves having to spend extra time up front.
Yeah, crafting those detailed descriptions to make sure the AI had all the context it needed.
So it's kind of a trade-off. You're potentially saving time on the coding itself, but maybe spending more time on documentation.
It is, and it raises an important question for the future of tools like UPLA.
Yeah, what is that question?
How do we strike that right balance? How can we make it easier for developers to provide the AI with the context it needs
Yeah.
without getting bogged down in excessive documentation?
That's a tough one. It's like finding the sweet spot between giving the AI enough information to do its job, but not overwhelming it with too much detail.
Exactly. It's a challenge that researchers and developers are going to have to tackle head on.
Okay, so we've covered a lot of ground here.
We've delved into the offline tests, the real-world deployment, and we've heard from the developers themselves.
We've seen the potential of HULA, we've seen the challenges, and we've seen the areas where there's still room for improvement.
It's a fascinating snapshot of where this field is right now and where it might be headed in the future.
But it feels like there's still more to the story.
You're absolutely right, because the researchers didn't just stop at gathering data. They took a step back
Okay.
and really reflected on what they'd learned, trying to extract those key lessons that could shape the future of human-in-the-loop software development.
All right, we're back for the final stretch of our deep dive into the world of human-in-the-loop software development.
The grand finale.
Exactly. And as promised, we're not just going to leave you hanging with a bunch of data points.
No data dumps here.
We're going to dig into those aha moments, the things that made the researchers go, that's interesting.
The real gems.
The gems, those lessons learned that could change the game for how we think about AI and coding, you know?
Absolutely, because that's where the real value lies. Right?
Totally. So spill the beans. What were those big takeaways? What really stood out to you?
Okay, so the first one, they called it out loud and clear. Detail is king.
So you're telling me that just chucking a random JIRA ticket at an AI isn't going to magically produce amazing code?
It's not quite that simple, no.
Okay, because I was kind of hoping it was.
Wouldn't that be nice?
It would make my life a lot easier.
But no, it turns out AI needs a little more guidance than that.
All right, so back to the details. How does that play into all of this?
Well, remember that performance difference we talked about between the SWE-Bench dataset and Atlassian's internal dataset?
Yeah, the AI was a rock star with SWE-Bench, but struggled a bit with Atlassian's code.
Exactly. And the researchers think a big part of that difference comes down to the level of detail in the task descriptions.
Okay, so you're saying those open source issues in SWE-Bench, the ones that read like mini novels.
The epic sagas of bug reports.
Exactly. Those were actually helpful for the AI because they provided so much context.
It's true, they're packed with code snippets, background information, all sorts of juicy details that the AI can really sink its teeth into.
While those agile-style JIRA tickets at Atlassian, they're more like, fix this bug, ASA.
Short and sweet, to the point.
Which works great for human teams who already have that shared understanding.
Right, they can fill in the blanks.
But for an AI, it's like trying to solve a puzzle with half the pieces missing.
That's a great way to put it. The AI needs those details to really understand the task and generate code that fits into the bigger picture.
So it's not just about writing more code, it's about writing better, more informative instructions for the AI.
Exactly. And this leads to a really interesting question for the future of this whole human-in-the-loop approach.
Hit me with it.
What are the essential ingredients, so to speak, for those AI-powered recipes? What specific information does the AI need to consistently produce high-quality code?
That's a great question because it's not just about expecting developers to suddenly become master technical writers.
No, nobody wants that.
It's about finding ways to make it easier for them to provide the AI with the context it needs, maybe even automating some of that process.
Absolutely. We need to think about how we can design systems that can pull in relevant information from all sorts of sources like documentation, code comments, even past project history, and feed that to the AI in a way that it can understand.
So it's like building a super smart research assistant for developers, one that can anticipate their needs and provide them with the information they need right when they need it.
Exactly. And that's a pretty exciting prospect, isn't it?
It is. It's like having a coding buddy who's always got your back.
The ultimate coding sidekick.
Okay, so lesson learned number 1, don't skimp on the details. What about the second big takeaway? What else did those researchers discover?
This one dives into the tricky question of what it really means for code to be correct.
Okay, because I thought if the code compiles and passes all the tests, we're good to go, right?
Well, it turns out it's not quite that simple.
Oh, this sounds ominous.
The researchers realized that just passing unit tests isn't enough to guarantee that the code is truly correct in the broader sense.
Hold on, for those of us who might not be coding wizards, can you quickly break down what unit tests are and why they're important?
Sure. So unit tests are basically like little mini experiments that developers write to check if specific parts of their code are working as expected.
Okay, so it's like a safety net to catch those bugs before they wreak havoc.
Exactly. They're a crucial part of the development process. But what the researchers found is that even when the AI-generated code passed all the unit tests, there were still cases where it wasn't really doing what it was supposed to do.
Wait, how is that possible? If it's passing the tests, what else is there to consider?
Well, think of it this way. You can write code that technically works, meaning it produces the expected output when you run those unit tests.
Yeah.
But it could still be a complete mess under the hood.
Okay, I think I'm starting to see the problem here. So the code might be giving you the right answers, but it could be poorly structured, hard to understand, or even introduce security vulnerabilities.
You got it. It might work in the short term, but it's a ticking time bomb waiting to explode down the line.
So simply passing unit tests is like checking off a box on a checklist. It's necessary but not sufficient when it comes to evaluating the true quality of the code.
Precisely. And this raises some really important questions about how we evaluate AI-generated code in the future.
Like, how do we go beyond those basic functional checks and actually assess things like readability, maintainability, security, and even the elegance of the code?
Those are the million-dollar questions, and they're not easy to answer.
Because those qualities are more subjective, right? It's not just a simple pass or fail.
Exactly. And it gets even more complicated when you factor in that different teams might have different standards or preferences for their coding style.
So it's not a one-size-fits-all situation. There's no universal definition of what constitutes good code.
Not yet, at least. And that's part of the challenge, finding ways to incorporate those more nuanced aspects of code quality into our evaluation methods.
So the second lesson learned is like a call to action. It's a push to develop new and better ways to assess AI-generated code.
Absolutely. It's about moving beyond those basic checks and really digging into the heart of what makes for great code.
So where does all of this leave us? We've explored this amazing new frontier of human-in-the-loop software development. We've seen the potential, the challenges, and the questions that still need to be answered. What's the key takeaway for our listeners today?
I think the biggest takeaway is that we're on the verge of a major shift in how software is created.
AI is coming to town.
It is, and it's here to stay.
But not in a scary, robots are taking over kind of way.
No, not at all. It's about collaboration, about humans and AI working together, each playing to their strengths.
Like a dynamic duo of coding awesomeness?
Exactly. And I think the key to success in this new era is going to be embracing that collaborative spirit.
Working with the AI, not against it.
Exactly. Providing guidance, feedback, and constantly refining the process.
Because the AI won't be perfect right out of the gate, it's going to need our help to learn and grow.
It's a journey, not a destination.
And as we've seen today, there's still plenty of questions to explore, like how to find that sweet spot of providing the AI with enough detail without overwhelming it, and how to evaluate code quality beyond just those basic functional checks.
Those are challenges that will keep researchers and developers busy for years to come.
But one thing's for sure, the future of software development is going to be an exciting ride.
Hold on tight, folks.
Thanks for joining us for this deep dive into the world of human-in-the-loop software development. We'll see you next time for another adventure in the world of tech.